Hey, how are we? By the end of this video, you should be able to find the equation of a circle when completing the squares required. Okay, let's pick it up. Solve the quadratic equation below by completing the square. So I have to remind you of completing the square because it's probably been a while. Here are some steps and guidelines for completing the square. You could copy these down if you feel that you need to copy them down. But I'm just going to basically go through these steps and guidelines to just sort of refresh your memory on how you complete the square to solve a quadratic. Okay, so first we have to put it in the form ax squared plus bx equals c. So we have to move the constant to the other side. So moving the constant to the other side gets us 4x squared minus 2x equals 5. Now, I can't have a coefficient other than 1 in front of the x squared. So I have to divide everything by a. I have to get rid of that 4 in front of the x squared. That's just the way it goes when you complete the square. So the 4's here cancel out when I divide everything by 4. And I get x squared minus 1 over 2x equals 5 over 4. Okay, now here's where the name completing the square comes from. Because you want to fill in this space here with a perfect square. So the space over here, you want to fill it with a perfect square so that you could get a perfect square trinomial. So the way that we get that perfect square, right, can't just come from anywhere. We get that perfect square by taking b, dividing it by 2, and squaring it. So, and then we're gonna take that and add it to both sides of the equation. So let me scroll down a little bit just to make some room, and let me just repeat that once again. So we're gonna take b divided by 2, square it, and then add it to both sides of the equation. So b is negative a half. Negative a half divided by 2 is negative 1 over 4. Negative 1 over 4 squared is equal to 1/16. So that completes the square, that completes that box. So I'm going to add 1/16 to both sides of the equation. So I add 1/16 on the left side to complete the square, and then, to keep the equation balanced, I have to add 1/16 to the other side. So now I get a perfect square trinomial on the left side. So the left side, I could factor, and I get two factors that are exactly the same. And the reason why I get two factors that are exactly the same is because that's a perfect square trinomial. And if you don't get two factors that are exactly the same, you're doing it wrong. On the right side, I got 5/4 plus 1/16, which gives me 21/16. Okay, just follow the rules of adding fractions. Get a common denominator, blah, 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 blah. You get 21 over 16. Okay, now I'm going to rewrite the factors as one factor squared. So I could rewrite the left side as x minus 1 over 4 squared, right? Because it's just being multiplied by itself. Scroll down. Now I'm going to take the square root of both sides. So I have x minus 1 over 4 squared equals 21 over 16. So now I'm going to square root both sides. So square root both sides. Remember that the square root of a positive number has a positive and a negative value. What do I mean by that? Well, what I mean by that is this. When you square root 21 over 16, you get a positive value and the negative value. And then on the left side, you're just going to lose the square because you're square rooting a square. So you just get x minus 1 over 4. And now you just follow the mechanics of solving for x, try to get x by itself. Add 1/4 to both sides. These cancel out. And you get x equals 1 over 4 plus minus radical 21 over 4. And that is our final answer. Okay, what can I use completing the square for? Well, it's another tool to solve quadratics, which means you now know 4 ways to solve quadratics. Quadratic formula, factoring, graphing calculator, and now completing the square. Well, you always knew that. I guess, I'm just reminding you of it now. Solving a quadratic means you are finding the roots, the x-intercepts of a quadratic. All right, now let's get to our learning target, because the whole point of reviewing that was so that you could learn how to write the equation of a circle when completing the square is required, as is the case here. Example 1 says, write the center radius form equation of a circle whose general form equation is that. So the process of going from general form to center radius form requires completing the square technique. So let's begin. We're going to group the x-related terms and the y-related terms. So that means I want my x squared group with that minus 4x and the y squared group with that minus 6y. So I get this. Basically, all I really just did was I just took this minus 4x and I just placed it there. Next, move the constants to the other side. In this case, there's only one constant, so we move that to the other side, minus 8, minus 8. Those cancel out, and we get this. So now is where the completing the square part comes in. Now we complete the square. So I'm just going to rewrite that, but I'm going to leave a space between 4x and the plus y squared, and I'm going to leave a space between the negative 6y and the equal sign. And that's where the perfect square is going to go. All right, so now, do you remember how to complete the square? So we have to take b divided by 2 and square it. So we have two b's here. We have, for the x's, b equals negative 4, this over here. For the y's, b equals negative 6. So let's work with the x's. So we gotta take b divided by 2 and square it. So that's negative 4 divided by 2, that's negative 2. Negative 2 squared is 4. Oops, I don't need this yet. Let's get rid of that. So that means I'm going to add 4 here. So let's add 4 here to complete the square. Now for the y's, b is negative 6, so negative 6 over 2 is 3, negative 3, excuse me, and then negative 3 squared is 9. So I get 9 over here. Now, you remember what I had there written before? Do not forget to balance the equation. Well, I'm bringing it back. Do not forget to balance the equation. Do not forget to balance equation. What do I mean by that? Well, I just added 4 and 9 to one side of the equation, so I have to add 4 and 9 to the other side of the equation. So let's clean this up a little bit. We get this here. Now we factor the perfect square trinomials, and we get this. So if you factor x squared minus 4x plus 4, you get x minus 2 times x minus 2. You factor y squared minus 6y plus 9, you get y minus 3 times y minus 3. You're supposed to get, you know, the same parentheses. So in this case, it's x minus 2. You're supposed to get the same parentheses for y squared minus 6y plus 9. In this case, it's y minus 3. Because the reason that happens is because these are perfect square trinomials. Okay, now rewrite the factors as one parenthesis squared. So we could rewrite x minus 2 times x minus 2 as x minus 2 squared. And we could rewrite y minus 3 times y minus 3 as y minus 3 squared. And this is our final answer, right over here. You could see that that's the equation of the circle in center radius form. So the center of the circle is, so I guess it helps, right, to go over that. So the center of the circle, can I hit extend page here? So the center of the circle is 2, 3, right? Got to change the signs. And the radius is what? The square root of 5. Oops. Okay, so that pretty much covers it for us today. I hope this video helps. Have a great night. Take care.